Morning, everyone. Get everybody in the room and we'll get started. Very glad to have everyone joining us this morning. Give it just another second or two to make sure we get everybody in. Maybe. All right, we'll go ahead and get started. Good morning. Happy Thursday, or Friday Eve, as some of my counterparts like to refer to it. We're very glad to have everybody joining us. Good morning, family. And if you are joining us on YouTube Live, as well as in the Zoom, you will chat your comments in and questions. We've got a full panel this morning of presenters and slides. So with knowing we've got a full plate, we're going to go ahead and get started. Don?
Good morning, Catherine. Thank you very much. We are so excited to be able to present this project this morning because the project has been incredibly successful and amazing. I saw a TV ad the other day from Amazon, and it made me think of auxiliary, and the ad said, think big, do big. And of course, our mantra in auxiliary is think bigger, but we also do bigger, all too. And a thought without action is just a thought. So our action has been really incredible. This project didn't happen on its own. We shaped the future on this project. We started 4.5 years ago. We did an incredible amount of research. Robert and I visited every major bus manufacturer, including going to Winnipeg, Canada, and back within 24 hours. We did extensive bus testing, trials. We put weights on buses. We visited other agencies that had electric buses. And we had a very large amount of partners that helped us along the way. And some of those partners are here today. We have Jason Hanlon from our consultant, who is the Center of Transportation and the Environment, or a nonprofit group out of Atlanta. Jason, can you tell us something about your agency and how you worked on this project?
Yeah, hello everyone. We are the Center for Transportation and the Environment. We are located in Atlanta. We have offices in LA and Minnesota. But our mission, like I said, we're a nonprofit, and our mission is to develop and deploy clean transportation technologies. So, and that's generally started in the bus area. Transit bus, as well as university and colleges. So we are certainly excited to be part of this one. This is a showcase fleet, and most of our projects, I think there's about 1,300 zero emission buses deployed around the country. But this one in particular is certainly a showcase fleet because it's a large fleet at a university. And there's certainly going to be a lot of eyes on this, and I think there's well, there already are, and I think it's certainly going to spur a lot more involvement around the country. So we're definitely proud to be a part of it.
Thank you, Jason. And next we have Jason Perry from the Office of Sustainability. Can you kind of talk about the project?
Sure. Good morning. Happy to join you with about 30 minutes notice to join this meeting. I actually was involved with this from Ron Hamlin's days. We initially applied for a Tiger grant, I think in 2014 maybe. And so when Don started looking at grants, we didn't get the Tiger grant, of course. I was able to reuse some of the calculations that I had helped Ron with to look at the fuel cost reduction, fuel use reduction, and greenhouse gas emissions reductions that were asked for in those grant applications. And so over the years, I've been keeping track of the changes in the parameters, different fuel efficiencies of electric buses that have improved dramatically over that period of time, as well as the improvements in or reductions in greenhouse gas emissions from the regional electric grid. So the environmental picture for these has continued to improve as we've been looking at this over the last several years.
Thank you, Jason. Next up, we were very lucky to get the finest and toughest bus inspector in the world. And he's actually joining us from Belgium this morning, Stuart Thompson. Stuart, can you say a few words?
Thanks for the nice intro, Don. Yeah, I'm have a small company headquartered in Belgium. I work around all over the world, Asia, Europe, where I am now, and the U.S. I've been in the bus business for over 30 years, and in zero emission buses for nearly 20, and have been involved with a multitude of projects with a lot of different kinds of customers in a lot of different places. And one thing that I find is that this particular team, the UGA team, is more capable of doing what needs to be done than most all customers that I've dealt with. It's a very good team, very strong, logical, easy to deal with, and absolutely steadfast on keeping quality, safety as the number one goals and objectives. Instead of a lot of customers are worried about things that are more or less superfluous. This is always about quality. So Don and company, it's been great working with you on this project.
Thank you, Stuart. And then finally, we have Eric Reynolds from Proterra, who is our bus manufacturer.
Hey, good morning, Don. Thank you for letting me be here and joining this today. I guess following after Stuart and Jason is pretty easy because I can echo a lot of what they say. As Stuart said, your team was top notch in working with, and I've been on part of many deployments at Proterra. And also to echo Jason, this is a showcase event. Proterra is the leading manufacturer of zero emission transit buses. In the US, we have over 500 buses in revenue service, over 1,000 sold, over 100 plus customers. And the UGA team is definitely first class and a great team to deal with. So I look forward to sharing a few more insights later on in the presentation. But thank you, Don, for letting me be a part of this.
Thank you, Eric. And we really appreciate that you have been a very transparent and honest company and very easy to work with. I'm going to share my screen now. We have a PowerPoint that we're going to run through quickly. And I'll turn the presentation over to Todd.
All righty. Well, good morning, everybody. All right. A few fun facts. Like I said, we're going to probably go through this pretty quick. Leave a lot of time for questions at the end. As you can see, we transport over 6 million riders a year. So we're a huge agency. When you compare that to Athens Transit, they do roughly just over between 1 million and 1.5 million riders a year. So we're huge compared to them as well. Currently, we do have 60 diesel buses and the 20 new electric buses. We also have, we got another grant for 13 additional. So that 20 will be 33 within the next year or so. Probably next summer at some point, we'll have all 33 electric buses on site. We are second in Georgia. TMARTA is the only thing bigger than us in terms of transit throughout the state of Georgia, which is actually pretty cool. And then we're second in universities. Texas A&M is, I can't remember how many passengers and just how big that operation is, but I know we're second to them. But they also have more acreage than I think Georgia has in the state in Texas. So they've got a lot of places they have to transfer. And then, as you know, all students, faculty, staff ride the city buses, our buses, everything for free, but it's not really free. It's based off the student fees and thing we do called NTD reporting, the National Transit Database, which helps get funding for Athens Transit and us. So we share that funding to reduce and keep the student fees low. And of course, about 75% of our drivers are student drivers, and they are phenomenal. To take a 19-year-old student and we train them from never driving anything but a car to driving a bus. So they're driving these buses just as along with our full-time drivers. So next slide, Don. So the benefits of the bus here at UGA are of obviously the sustainability and the environment. We're working on some contingency plans, and Jason Perry actually helped me out on this. We put what we had been using for buses and what we're planning on using coming up for fall semester, and using 18 of the 20 electric buses, leaving a couple off for our campus tours, which is a very good thing to have our tours going on an electric bus. We reduce our carbon emissions by roughly 5 metric tons per day, which is phenomenal, just by what we're looking at with the new routes and all that. So obviously that is huge, taking the diesel buses off and getting rid of the carbon emissions. The reduced operating costs, when we started looking at this and looking at the cost of electricity and that what we're paying, the bus is actually going to cost us about $5 a day to run versus a diesel bus, which is right around $95 to $100 a day to run. That's just fuel. That's not counting any maintenance or anything like that. So it's a phenomenal cost savings. Again, it'll just help the operation and help keep all the fees low for everybody. This last year, before our current situation, we actually were working very closely with 4 capstone projects with the engineering group. They were a great group to work with. They were coming up with different scenarios, what we could do using the buses for exportable power, working how to do different things with the charging, just a wide variety of things. And we also had 2 National Science Foundation grants involved with this as well. Again, the bidirectional energy for emergencies, like I said, they were working on that project. It is possible where a bus becomes basically a mobile generator. It can keep the dining halls running. In my previous location, when we were looking at doing the same type project, the thought was we would actually be able to power a hospital with several buses that have plug-in points around the building. The ride is built, like I said, like the electric vehicle ride, it's built for long life and long public transit users. It is phenomenal. If you haven't been on it, definitely when we have them up and running, get out there and ride them. They're quiet, they're solid. Don says it constantly, and I actually have to agree with him. It is probably one of the best buses ever built. It is absolutely phenomenal to ride. The promoting UGA in Georgia, and that's going to kind of go with the last bullet too, the shaping the future. We get constant inquiries based on the electric buses. How did we get the grants? How did you do this? What are you doing to charge? How is this? We've had people from Virginia, people from California. I've had a conversation with someone from Vancouver. I know we had a group from Connecticut come down and visit us as well on campus. So we are truly the leader in the industry right now for the universities. So we get a lot of people, a lot of inquiries, like Don says, daily. If not daily, it's every other day, and then multiples in a day. So truly is going to be a great thing for the University of Georgia, and auxiliary and parking and transit are going to be a huge part to shape that. So that's my 2 slides. I'll pass it back to Don now.
Thanks, Todd. As Todd said, we were able to get 2 grants for these buses. The only drawback to an electric bus is that it costs more upfront, and an electric bus costs about $822,000 compared to a $450,000 diesel bus. So we needed to get funding somewhere. But we had an amazing story to tell, and I've actually talked with evaluators who voted for our projects from government entities, the state and federal, about why did you vote for us afterwards. And they said two things. For the first grant from the state was that you have 40,000 students ride your bus every day. They're in the formative period of their lives, and the electric bus, as Todd said, is a fantastic ride. It's quiet, it's smooth, it's no emissions. And so you're building lifelong public transit users, and that's something that we really aim for. And then the second reason, which is even more important, is that we have researchers, both faculty and students, who can research the transit industry, and we can provide field assets with our electric buses and our chargers, and also with all our data that researchers can use. And so they gave us a $10 million grant for that. And with that, we got 20 buses. And then we built a $1 million charging facility. We have 12 very high-powered chargers. We can support 48 buses currently, and it can be expandable. And then we also developed maintenance and operating expertise, and we're going to talk about that a little bit later. So now we have a second incredible story to tell. We have the expertise, we have maintenance, we have the facilities, we have the chargers. And so now this second story is every dollar that you would give us would go into electric buses. We don't need, and we don't need anything else. We have a tremendous bang for the buck, and every penny that you get us is going to go into electric buses and taking diesel buses off the road. And we've proven ourselves, we can do it. And there's no risk in giving us money. And so the federal government gave us $7.5 million, and that equated to 13 buses. And now we have a third amazing story to tell. And we've already started working on this, and we can build a solar canopy over our parking lot. And Thomas, I think, will get into this a little bit later. We've already researched it, we can do it. And now we have a story that we can drive buses on sunshine, and I know somebody will give us that money. It's just a matter of time. So a solar panel over our entire transit parking lot. Okay, and now I'm gonna turn this over to Thomas.
Hey everybody, I'm Thomas. I'm a master's student here and the project coordinator for the electric bus project. And I'm going to talk to you guys about some of our local partners and some auxiliary parts of this project that weren't exactly the bus, but cool stuff that came out of it as well. We worked with a bunch of different partners here at UGA to get this knocked out. We had to redesign our entire transit facility. The parking lot over there needed a lot of charging stations installed, and we did a really good job with that in conjunction with OUA and Breedlove Land Planning, who was our general contractor on that. We redesigned most of the parking lot to accommodate these buses. We'll get into some photos in the next couple slides. We worked with the Office of Sustainability to get the initial grants and to talk about the improvements to sustainability. College of Engineering have provided 3 different capstone teams of students who are doing their final project here at UGA. And 3 of the teams in the College of Engineering selected transit to work with. And we're really interested in learning about our buses and making improvements for their final project. And we'll get into detail about those guys in a minute. They had some really cool ideas and stuff we can actually use in practice, which I think is really awesome. It's not just a school project for them. We're going to be able to take things that they produce for their project and use it in our day-to-day operations. FMD helped us out with the construction over at our facility along with OUA and produced some pretty cool, I'll show you on the next slide, their arms to protect the rather fragile charging cables, and they were custom built for us. So they did a pretty cool job with those. I think they're amazing, but I'm a nerd for that. And finally, the Department of Geography has sensors installed on our buses, and they're studying climate change as we drive around, which I think is amazing. Something I would never have expected us to be able to help with. It's pretty cool. Slide, Don. All right, so what you're looking at here is a customized metal fabricated arm that FMD's metal shop put together for us. We've got a bunch of these, one for each charger, and the point is to keep the thing you see in the foreground. That's our plastic charging piece that it's like plugging your phone in. You just plug in that to the bus, and over a period of 3 hours, it'll charge up the vehicle. But that little guy is a little fragile, and we don't want it dragging around on the ground or getting beat up. So we've got these cool arms that can service 2 buses at once. They're so overbuilt, so robust. It's one of the highlights of the project for me. I think they're the coolest little gadgets that we got. There's another view. You can see they can swing between the 2 buses, and one charger will service 2 buses, not at the same time, but you can swing them around. Here's our pricing. We have a really cool story to tell there. You wouldn't believe it, but we're paying about 2 cents per kilowatt hour to charge these buses. And we know what time of day the rate's going to be lowest 24 hours in advance. So we can get all the buses charging at our lowest possible rate, which usually comes in the middle of the night around 1 in the morning. Here's a graph of a typical charge day. As you can see, that peak on the far left side is when we load the grid to charge our buses, and it peaks there about 1:30. That's the lowest price in a rolling 24-hour period. And if you look at the scale there, by 3:30 we're done charging all the buses. They charge way faster than we thought, even as advertised by Proterra. So that's really cool. They're flying. We're a big fan of the charging speed. All right, the slide that you're looking at now is one of the engineering team's final project, and it's a redesign of the Proterra charger. They did a great job with that, and they got really in depth with it and produced kind of their own design for a electric bus charger. And this is something that we could use in real life if they were to manufacture something like this. Here's the second team. They used, their final product was like a dashboard where we can model, where we can optimize a route based on temperature and elevation and passenger load, seeing where people get on and off the bus, where gradient on the road is most severe, and what time of year we're running it, because temperature affects buses. Like the battery will run out quicker in the midwinter, and they produced a little piece of software for us there. And finally, we have our emergency power system that Don talked about earlier, where the bus can be used as a mobile battery to power up a building or a medical facility or some such unit that requires power in the event of an emergency. We had power statistics for multiple buildings on campus. For example, one bus could power the Carlton Street parking deck for 14 hours, or say Snelling Dining Commons could be powered by one bus for 3.5 hours. Our last slide here is one of the project teams that we're planning to implement in the coming years. It's a solar panel design for the large parking lot to the right side of our facility. And their team did a great job modeling how much energy we could save or bank essentially by holding a solar panel. And we plan to take power and return it to the grid in exchange for an even lower cost on our energy. Or we could take solar power and bank it into a battery on site and use that to charge our vehicles in addition to grid power. Is there another slide? Oh yeah, here's one of this is two of the teams together at once, taking a look under one of the buses. These are some of the engineering students there, as well as their project sponsor. It was a pretty cool day. They seemed very, very interested.
Thank you, Thomas.
Yes, sir.
Now we're going to turn it over to a couple of our operators, Eddie Salisbury, who's a supervisor, and Rick Klumpa, who's a bus operator. And tell us what you think about the bus, how it drives, and some of the advantages or differences between diesel buses. Go ahead, Rick and Eddie.
Yeah, good morning, everybody. This is Rick. I was fortunate to be one of the first drivers to get an electric bus on the route that I was driving. And I can say that I didn't miss the diesel bus at all. These electric buses outperform the diesel buses just about every way possible that I can tell you. With the diesel buses, there's a power transfer lag that goes when it's accelerating, where, you know, when you accelerate in a diesel bus, it takes a while for that acceleration to ramp up. These electric buses have 100% power available all the time. So there is not that ramp up. So it makes for a much smoother ride and acceleration as well also. Not really worried about changing gears or having a transmission to worry about as well. So that makes for a much smoother ride for you, the driver, as well as the passenger involved as well also. I would also like to talk about the regenerative braking that's on these electric buses. It's a great feature. As far as I'm concerned, being a driver, I barely have to use that brake pedal at all. I take my foot off the accelerator, the regenerative braking kicks in, slows down the bus. You can coast to a stop if you work it correctly and barely have to touch that brake pedal whatsoever. Also, another nice feature is the hill lock. We used to implement with the diesel buses a heel toe feature on a hill, where we would have to keep our toe on the brake and transfer our heel over to the accelerator and push down the accelerator to get the bus going up a hill. With the hill lock, you come up to the hill, the motors will lock the bus in place so it does not roll backwards. And as you ease your foot on the accelerator, the bus will take off and go up the hill without that slide back, and also jerking the passengers, front or backwards. I've driven many heavy vehicles in my life, and my personal opinion is this Proterra electric bus is one of the most stable vehicles I've ever driven. It is solid from front to back. I can't say enough about it. I will pick an electric bus over a diesel bus any day of the week and twice on Sundays.
Thank you. Rick, Eddie, you want to join in?
Yes, sir. I concur with Rick. I really like driving the buses, the electric bus. The model we're using now is the Catalyst E2. It's extremely efficient, has unbelievable power. As you can see, it set records for acceleration and torque. Accelerates twice as fast as the diesel buses. The charge on the bus is amazing. It's also set a record for any electric vehicle, that's including cars, for the longest travel. The body is light. It's guaranteed to last for 12 years, but we think it'll last longer than that because of it. The bus has 2 motors, which it can go on one, drive on one motor. One of the best things about the electric buses, to me, is the is the data feedback that we get to improve the efficiency of our fleet. So right now we're using the Apex data analyst program. It's currently in beta testing, but it serves as the potential to make our fleet one of the most efficient in the world. So right now, year to date, we've driven over 14,000 miles on our electric buses. This in turn has saved us over 3,700 gallons of diesel and about 53 gallons of barrels of oil. So as Todd said, we are greatly reducing our carbon footprint. Just to give you a few facts about the system, most of our energy is used from the powertrain and the defrost system. But as Rick stated, we were able to get some of that energy back by using regenerative braking, which basically allows the bus to stop by itself. One of the most unique things I found about the Apex system is it actually tracks the efficiency of the buses based on the weather conditions for today, of that day. So like sunny days, the buses will be more efficient opposed to rainy or humid days because of the amount of energy that's lost from the defrost system. So knowing that little tidbit of information will allow us to better plan and make us more efficient with our service. So next slide.
Okay, thank you, Rick and Eddie. And one of the advantages that we had is that Proterra is only located 90 miles away in Greenville, South Carolina. So we were able to have lots of people visit the plant and kind of learn the bus from the inside out. We took not just operators and maintenance personnel up there, but you can see we took accountants and financial people and marketing people to get everybody involved with the bus. So let's talk a little bit about maintenance. Nick, can you take over?
Yes, this is back up one, Don. Maintenance was able to go through the entire bus build and see it from start to finish. So we was able to see where all the lines, cables, and every component is located in the bus, which is a great time saver for maintenance. Next, Don. Terry was always glad to have us on site. Terry staff was great to answer any questions we had, show and explain what, where, why something was located there. We worked with like you said, one of the best inspectors in the world and going over the buses from front to rear. Next, Don. This is top of the bus where maintenance found some issues, like the surge tanks you see there was totally exposed to anything that was hanging low, like limbs or anything else that could hit it and bust a surge tank. We also found other issues on the bus, which we expressed to Terry, and they was happily, to resolve these issues with us. And they built access panels in this slide to go over the surge tank where can't nothing hit it and break it, and also reroute the cooling line.
Sorry, Nick, do you want me to go back?
No, sir, I'm fine. Thank you, Don.
Are you finished?
Yes, sir. I see. Yes, sir, I'm good.
Okay, thanks, Nick. Like I said before, this project has grown by leaps and bounds, further than any of us could ever imagine. And we have a lot of people, not just transit agencies, not just universities and municipalities, but I never thought that there would be so many people who would want to partner with us and learn from us. Again, we thank CTE, Proterra, and TWA as Stuart, our inspector. Twice we've talked to the Union of Concerned Scientists at their annual convention. They are a group of scientists who are worried about global warming, and they were just so enthusiastic about what we're doing that we presented to them one year, and they asked us to come back and present the next year. And also the American Society of Civil Engineers, we've presented at their conference. They're people who are really interested in the electric grid and the impact of electric vehicles on the electric grid. And they've actually asked us to come back a second time. And the Environmental Protection Agency has asked us to speak with them. And of course, now we're in closer partnership with FTA and the GDOT, Georgia Department of Transportation. And with our new grant, there's a lot of specialized training, drug testing, et cetera, that we need to do that they will provide that'll be really fantastic for transportation and parking. And so with that, that includes our presentation, but I'd like to give our partners a chance if they would like to say anything else before we open it up to questions. Eric, Stuart, Jason, anything you want to add before we take questions?
Probably make it 5 hours. If we're following it.
Hey, Don, this is Eric Reynolds. I'll just say real quickly, one of the neatest parts of this project for me, and I know Nick touched on it briefly, but I think it might have been overlooked that you really did bring every driver, technician to our plan. And I know Todd and Nick and Thomas and you brought many groups there. And that was a big part of this, I think, to really get the drivers buy-in. I think that's really important. We don't see a lot of that in the transit industry. And the fact that, again, I know that Greenville is close to Athens, but the fact that you were able to do that and the fact that you took the time and the resources to get everyone.
I lost you there a second, Eric.
That's all right. I thought you muted me.
Catherine might have muted you.
I talk a lot.
Wasn't me.
Anyway, just wanted to say thank you for, that's a unique part of this project, and I think it's something that's very important.
Thank you,
Eric. This is Jason Perry, and I just wrote down a couple of notes from my spreadsheets that I've got on my computer. I just wanted to point out that the up-to-date calculations that I have show a 70%, that's 70% reduction in net greenhouse gas emissions from operating a diesel versus electric the same amount of miles. And that's incredible. And it actually improved from 68 to 70 over the last couple of years once I updated the grid emissions factors. And then part of that and the beauty of the electric bus over a diesel bus was some of the data that Ron Hamlin pulled years ago from some of the older buses in operation showed an average, this I think was for about a selection of maybe 10 buses at the time, average of 52% idle time. So that's sitting at stops, sitting at traffic lights, that sort of waiting for people to cross crosswalks and that sort of thing. And so when you're running a diesel bus, obviously it's sitting there running and burning fuel. When you're running an electric bus, it's not really, it's just running the systems and not driving it. So that's a really great advantage of these things.
Thank you, Jason.
To,
Jason?
to add on to that, transportation accounts for about 30% of all greenhouse gas emissions globally. So this is a significant portion of that because medium and heavy duty transportation is a big part of that. But since we see so many of these, we've been involved with about a third of all zero emission bus deployments in the country. I did want to give a little bit of background to this. We deployed the very first Proterra bus and managed that project, which was 12 years ago. And that particular bus actually went to Columbia, South Carolina. So that kind of spurred an industry. Proterra took that. It was an innovative bus, purpose built for electric drive. No one else had done that, and have grown that. And I think every year since then, Proterra's innovated in some form or fashion, whether it's through battery developments, and even what Georgia's getting is advanced. It's more advanced than any other bus that's out there right now because of the duo power drive and other innovations. So we're certainly excited to see the efficiencies from the duo power drive, since this is one of the first deployments in the country. You know, I think there's going to be a lot of benefits, but it's also interesting to kind of see this progression through the Southeastern Conference schools, where, you know, you kind of had that first bus at South Carolina, and now a big deployment at UGA, which brings its own set of challenges. You know, deploying a large fleet is not easy. Most of the deployments around the country are between 1 and 5 buses, because that's pretty easy to do with putting, you know, installing that amount of charging infrastructure. But to do charging infrastructure for 20 and 30, 40 buses for fleets that have never had to use electricity as a fuel is a challenge. And UGA did an extremely good job at deploying that charging infrastructure. It was one of the smoothest deployments I've seen. And one other thing I think that auxiliary services has done an amazing job at is going out. They did their homework. They knew exactly what they wanted. And since we've been involved in the project for the last 2-3 years, that hasn't changed. And Don and his group have focused, and that's made, there's been no wishy-washy. They knew exactly what they wanted, and they went out and got it, which is pretty unique and pretty impressive, and one of the biggest reasons why this project's going so smoothly. So yeah, we're excited.
Thank you, Jason. Stuart, do you have anything to add? I think you're muted, Stuart. Sorry about that. Catherine, that completes our presentation, but we'd be very happy to take questions.
Okay, I'm actually gonna pull Robert in if he's still here, and let him speak to this, because I know this is one of his big wheelhouse wins too. So
what I can say is that
There
you
you
guys put together an incredible panel today. Stuart, always good to see you. Jason and Jason, both good to see you guys too. One of the things that we had the phenomenal opportunity to do, which others didn't have the chance to do, was to actually be close enough that we could bring our teams to the plant and actually get them in there. And I know Nick talked a little bit about that. It was kind of an important piece in making sure that people saw the process all the way through. Stuart and I have had some great conversations. He and I have some similar backgrounds, and so it was really fun to be able to go through and talk about some of these things as we're going through the projects. Don has had a great time being able to connect with different people, and Jason Hanlon, you know, as a part of our team externally to us, great resource, great ability to be able to bring that in. Todd and I have been able to work on some projects actually with Dale from Proterra for about the past 8 years. So we've been looking at electric buses. We've been looking at different technologies to be able to bring it into the campus the way that we did. Really fun to be able to do that. And, you know, Jason mentioned that it was a challenge when you're looking at bringing in buses, and especially in the number that we did. But what we really looked at was being consistent and looking at how we could do it, not as a challenge, but as an opportunity. And even when you get down to looking at the arms that we built for having the cables for the chargers, the cost of repairing and replacing those cables, we had a lot of pushback from people saying, you don't need these arms, but we built the arms very deliberately so that we could reach from one bus to the other without ever having to compromise that cable, because that cable could be a very expensive part to replace. And we wanted to make things easier. And it's something that we've had a lot of interest in people looking at and seeing what we're doing. And then with Don working with the engineering department and bringing them in. I remember the first time we worked with the engineering students, the first time we brought in the dean of engineering in to talk about this concept, and being able to bring the students in. And it was really kind of cool because Eric and his team from Proterra brought a bus down so that students could not only ride it before we ever did anything, but get up underneath it and see it and feel it and really start to get an understanding of what the electric bus was, as opposed to just looking at things on a piece of paper. So we've developed a great partnership there, and it's just been a really fun component. Jason Perry talked about the emissions component. And that's one of the things Ron and I, one of the first discussions Ron and I had when I came to campus was, why are we running all diesel buses? And we started having those discussions and going out and looking at different ways that we could attack that, because really in this day and age, running an all diesel bus fleet on a university is a little archaic. And so we now are moving forward, but not just with us, but have been able to really move the needle forward for others to think about how this is possible. Again, going back to Stuart, you know, his ability to go through those buses and look for those details, but not just that, also being able to work with our mechanics so they really could go through and see that every component all the way through was an incredible addition. I've worked many places and we've never been able to bring in that component of getting people up to speed on that like that. So great presentation, guys. I'm glad you were all able to come together. Love the project. The buses look incredible. We get compliments by every rider that rides them. So back to Don.
Thank you very much, Robert. Catherine, we're happy to take questions.
All right. So Jason Hanlon kind of answered, but I want to go back and maybe get, because the people on YouTube live can't see the chat. So the question had come in that said, can someone explain how the smaller batteries, or how the batteries are made up of smaller batteries, and how that is an advantage? And I was hoping one of them could elaborate. Jason, if you could elaborate on that for the benefit of our YouTube watchers.
Well, let me help with that one, because we have the foremost battery expert that I've run across, and actually when we went to New Flyer, Robert taught their engineers about batteries. So Robert, would you mind fielding that question?
I could talk a little bit about it. When you're looking at batteries, they're built up of cells. Whether you're looking at, you know, if you take apart any of your equipment that you have today that is battery operated, it's actually made up of many different batteries inside that cell pack that you have. And the same technology works on the buses as well. you build individual cell packs that go into them. We're always working on advancing the design. The original batteries in like a car are lead acid, and these are a different technology than that. But when you put in those individual cells together and you make packs, you're basically doing the same thing you do with an electric grill or anything like that. You're building a battery pack out of individual cells, and you're connecting in between them and connecting in a way that you can balance the load. So you can always make sure you have a consistent voltage coming out of that pack. And what happens when you start to have battery failure is not that you have that entire cell, that entire pack fail, but you usually have one cell within that that is starting to have problems, either the connections or other pieces. And one of the battery plants that we went at, one of the things that they were having problems with was actually when they were welding the cells together, they were getting a bad connection. So it's something that really is critical in being able to look at it, because the batteries that they're building in those battery packs are actually coming from a battery cell that is designed not just for that purpose. So they can stack them together and create the volume of battery for the storage that's needed out of those individual cells. And they can design the trays that need to be able to hold that. And that way you can put the load in different components of the bus. Originally, when we were looking at electric buses, they were putting batteries on the ceilings, they were putting batteries in the posts, they were putting batteries underneath the buses. And it was really adding a lot of load to the bus itself. But battery technology has advanced so much that the storage capacity in a battery today is much greater than it was even 5 years ago. So they've been able to reduce the number of batteries and the number of cells to produce the same volume of power coming out of that battery pack. And that allowed them to take it off of the roofs and out of the pillars and really stabilize the battery load in the bus a lot better. When you think about having a lot of weight on the top of a bus, you have a lot of problems with swaying and different things. So it really comes down to you're using people like Sony and Panasonic and different battery manufacturers to produce cells that then can go stack together to produce the amount of voltage and the amount of storage that you're looking at. So hopefully that was okay.
Thank you, Robert. Other questions, Catherine?
So another one that was asked and answered in the chat that I want to be sure we catch was about the painting of the buses. They have the and the question about the question was about how are they painted, and in fact they are not painted. They are wrapped, and I was hoping somebody could speak to that.
Todd, do you want to answer that one?
Yeah, so we get them from the factory. They're a flat white. They're wrapped. The wrap sometimes comes out a lot better. It's a lot easier to maintain overall. That way, if you need to change down the road, just peel it off and put a new wrap on it. It's a lot cheaper than the paint too. So, and the wraps are pretty high durability. Previously, I mean, where I was before, we had a wrap that was on for 3 years. Starts to fade a little bit, but it was still intact. So the wrapping is actually not a bad thing. It actually makes the buses look really crisp. So that's the route we took on these.
So a wrap, just for those of us that don't speak all of that language, that is actually a lot more like a decal. It's a sticker. It's a giant bus-sized sticker.
Correct. And it takes about a day to a day and a half to put it on each bus.
Okay.
Does
the person?
If Eric's still on, he might be able to talk about the body itself, which is, it's not like an aluminum body or a steel body. Eric, are you still out there?
Yes, Robert, I'm on, and that is correct. Because Proterra is built from the ground up to be a battery electric bus, we are not retrofitting or modifying an existing bus that's purpose built to be something else. And turning that into an electric bus. So from that, we start with a composite body, and that's very important for several reasons. It's very safe, very durable, but also, Robert, you touched on battery placement. So by not using a steel body bus where we remove a diesel engine from the rear engine compartment and potentially put batteries there, we start with a composite body that's purpose built. And then that composite body then has the compartments essentially to put the batteries underneath the floor of the bus. So yes, we are not using a metal a metal or steel body bus frame.
And that composite body starts out with a white gel coat. And so instead of us painting the buses, we're using that white gel coat as the base and then putting the wrap on top of that.
Yes, correct.
Okay. As far as training goes, do the person that is operating the bus, is there a training difference as far as the diesel versus the electric bus as far as the driving is concerned?
Eddie, can you answer that one?
Hold on. Can you repeat the question, please? I'm trying to mute myself.
I was asking about the training. Is the training teaching someone to drive the diesel bus versus the training involved in the electric buses? What's the difference?
It's pretty much the same. The major difference is the electric buses, the turn radius is a little less than the diesel. And the bus is also a couple feet longer. So getting used to making the turns is a little different. I think what I've found most drivers struggle with is learning to use regenerative braking to make the buses more efficient, because actually hitting the brake is ingrained in your muscle memory. So you constantly do that. But as you drive an electric bus, that's actually bad for, the efficiency of the bus. So learning to regenerative brake and let the bus kind of coast and stop on its own is probably the most hardest habit to break when training to drive an electric bus.
Okay. And I see that that Catherine Smith is on. Kathy, you want to speak to the training?
Hi, everyone. To just kind of go over the electric bus training that we do for each of our drivers. So all of our drivers are already certified to drive our diesel buses. And then we bring them in for a classroom training session that goes over all the differences with the electric buses from the diesel buses and all of the new features, where all the buttons are, how to run that bus most efficiently. Then they're taken out on the road without any passengers to get a feel for the bus, because as Eddie stated, the turning radius is different, the braking is different, so they've got to get used to all of that before they have passengers with them. And then on their first driving shift with passengers, a supervisor or a trainer rides out with them just to make sure that they're comfortable, can answer any questions on the fly, and can monitor that driving for a little bit.
Okay. All right. I was looking to see if we had any other questions. Any last minute questions? We do definitely want to thank everybody, all of our panelists, all of our that have joined us. It's been amazing to hear from the sources themselves. That was an awesome surprise for us today to have the sources on the call as well. And a thank you to our transit team for all that they've done as far as the grants and all of the labor intensive to get all of this off the ground. It's awesome. This is a huge thing for auxiliary to be a part of, and it's exciting. I'm excited to watch, but I think we're good. There were the question came in about certain bus routes getting priority for the electric buses, and the electric buses have been prioritized based on route, as mileage and terrain affect the efficiency, according to Kathy. So thank you for that, Kathy. And with that, we're at our time, and I'm going to close out this afternoon. we have a session at 2, and the session at 2 is over what do you want? And Don, do you have any last comments before we go?
Thank you, Catherine. I should stress again that what has made this project so amazing is that we had so many team members involved, from operators and maintenance, from both UGA departments and also external teammates. And what made it so successful is that everyone was so excited about the project, and everyone did their very best to make it happen. And that's why we've been successful, because it involved a whole lot of experts and different points of view, and that's how things came together.
Awesome. All right. Well, thank you everybody for joining us, and we look forward to seeing you this afternoon at 2, and we'll see you soon. Have a great rest of your day. Thanks everybody.